Hello and welcome to our SIAM course on power generation technologies. My name is Kundan Sahu, lecturer in mechanical department from Uday Prasad Uday Government Polytechnic, Durg. I am here to teach module 4 of power generation technologies. In my previous video lecture, we have discussed in details about introduction of nuclear power plant and elements of nuclear power plant. In this video lecture, we will discuss about classification and different types of nuclear power plant reactor. So, let us discuss about the classification of nuclear power plant. Nuclear reactors are classification on the basis of following. First point is coolant. On the basis of coolant, use the reactors are classified as first gas cooled reactor such as air, CO2 or helium. Second, liquid cooled reactors such as boiling water, pressurized water, liquid metal cooled reactors. The boiling water cooled reactor serves directly as a steam boiler. In the pressurized water cooled reactor, the water is under pressure in excess of saturation pressure at the maximum water temperature in the system, so that it cannot boil in the reactor. Under classification of nuclear reactor, second point is principal product. On the basis of principal product, the reactors are classified as first research reactors to produce neutrons, second power reactor to produce heat, third is breeder reactor to produce fissionable materials, fourth is production reactor to produce isotopes. Next point, neutron energies, which is the classification of nuclear reactor. On the basis of neutron energies, reactor are classified as first fast fission reactors, second intermediate or epithermal reactors, third thermal reactors, that is low energy reactors. Next point is fuel moderator assembly. On the basis of fuel moderator assembly, reactors are classified as first is homogeneous reactor, in which the fuel is in the form of liquid such as uranyl sulphate dissolved in water. Second is heterogeneous reactor, in which the fuel is in the form of solid, bar, rod, etc., surrounded by the moderator. This is the most common reactor. Next classification is fuel state. On the basis of fuel state, reactors are classified as first solid fuel reactors, second liquid fuel reactors, third gas fuel reactors. Next classification is fuel materials. On the basis of fuel materials, reactors are classified as first natural uranium with uranium 235 reactors, second enriched uranium with more than 0.71% of uranium 235 reactors, third is plutonium 239, plutonium 241 or plutonium 239 reactor. This is artificial reactor. Fourth is uranium 233 reactors, which is also artificial reactors. Fifth one is fertile materials are uranium 232 and plutonium 238. Next classification is construction of core. On the basis of construction of core, reactors are classified as spherical, cylindrical, octagonal, cuboid, slab and annulus reactor. Next classification is moderator. On the basis of moderator, reactors are classified as water, heavy water, graphite, beryllium, hydrocarbon reactors. Nuclear power plant use various types of reactors to generate electricity. These reactors differ in their design, fuel and cooling system. Here are some of the most common types of fission power reactors types. Different types of reactors are there: pressurized water reactor PWR, boiling water reactor BWR, fast breeder reactor FBR, gas cooled reactor GCR, liquid metal cooled reactor and last one is can do type reactor. So, let us discuss all types of reactor in brief. So, first type is pressurized water reactor. It is the diagram of pressurized water reactor. Different components, elements are there. So, let us discuss this pressurized water reactor. A pressurized water reactor is a thermal reactor where slightly or highly enriched heterogeneous clad uranium is used as fuel and ordinary water under high pressure is used as moderator, coolant and reflector. The arrangement of pressurized water reactor is shown in figure. The pressurizing tank included in the circuit maintains the constant pressure in the circuit throughout the load range. The pressurizer is simply a pressure vessel with a heater at the bottom and a water spray at the top. The water in the pressurizer is boiled and converted into steam by electric heating coil before starting the reactor. This results in the increase in pressure of the primary circuit. If the primary circuit pressure becomes too high, cold water is sprayed into the steam in the pressurizer. This condenses the steam and reduces the primary circuit pressure. So, let us discuss about the working of pressurized water reactor. The water in the primary circuit gets heated by absorbing the fusion energy in the reactor core and same energy is given in the heat exchanger to generate the steam in secondary circuit. In order to prevent the boiling of water in the core, it is kept under pressure of about 130 to 150 bar. It helps in absorbing the heat by water in the liquid state in the reactor. The steam produced in secondary circuit is used in a conventional way in the steam power plant cycle as shown in figure. The water coolant from heat exchanger is recirculated to the reactor with the help of coolant pump. In this reactor, the water flowing through the reactor becomes radioactive. Therefore, this primary circuit must be heavily shielded to protect the operators. Next point is advantages of pressurized water reactor. Water is available abundantly and cheaply. There is great saving in cost. Second advantage is the reactor is very compact and has high power density. Third is a small number of control rods are required as steam is not contaminated by radiation, inspection and maintenance of turbine, condenser and feed pump is possible. Great energy is extracted per unit weight of fuel loaded. Next point is disadvantages of pressurized water reactor. Following disadvantages are: first is its capital cost is high due to heavy and strong pressure vessel is required in the primary circuit. The thermodynamic efficiency of this plant is as low as 20% due to low pressure in the secondary circuit. Next disadvantages is it requires enriched uranium fuel. Cost of enriched uranium is high. Next is it is necessary to shut down the reactor for fuel charging. The corrosion problems are more severe as the corrosion is accelerated in the presence of high pressure, high temperature water. Our next type is boiling water reactor. This is the diagram of boiling water reactor BWR. So, let us discuss about the boiling water reactor, its construction, working, advantages and disadvantages. In boiling water reactor, enriched uranium is used as fuel and water is used as coolant. Moderator and reflector like pressurized water reactor, except the steam is generated in the reactor itself instead of separate steam generator. The arrangement of the boiling water reactor power plant is shown in figure. The feed water circulated in the reactor is converted into saturated steam by transfer of heat released by fission in the reactor core. This steam is supplied to steam turbine working on convention power plant cycle. The mechanical power produced by the turbine is converted into electrical energy by the generator. Next point is advantages of boiling water reactor. The pressure inside the reactor vessel is less than the pressurized water reactor, as water is allowed to boil inside the reactor. Therefore, the reactor vessel can be much lighter than pressurized water reactor and reduce the cost of pressure vessel considerably. It eliminates the use of heat exchanger, pressurizer, circulating pump and piping. Therefore, the cost is further reduced. The thermal efficiency of this reactor plant is 30%, considerably higher than pressurized water reactor plant. The metal temperature remains low for given output conditions. Next point is disadvantages of boiling water reactor. The steam leaving the reactor is slightly radioactive. Therefore, light shielding of turbine and piping is necessary. It cannot meet the sudden chances in load on the plant. The power density of this reactor is nearly 50% of pressurized water reactor. Therefore, the size of the vessel will be considerably large compared with pressurized water reactor. It requires enriched uranium as a fuel. Next type is fast breeder reactor. It is the diagram of fast breeder reactor. So, let us discuss about the fast breeder reactor. The process of converting more fertile material into fissile material in a reactor is known as breeding. Its importance lies in consequence that all available fertile material can be converted into fissile material. In fast breeder reactor, the core containing uranium 235 is surrounded by a blanket of fertile material uranium 238. In this reactor, no moderator is used. The fast moving neutrons liberated due to fission or uranium 235 are absorbed by uranium 238, which gets converted into plutonium 239, a fissile material. This man-made fuel plutonium 239 can be used for further fission. Similarly, thorium 232 can be converted into uranium 233, which is also a secondary fissile material. Therefore, these types of reactor are important since they not only produce heat, but also produce more secondary fissile fuel than fuel consumed in the reactor. Since India has massive reserves of thorium and limited resource of uranium, development of these fast breeder reactors are important for our country. The arrangement of liquid metal fast breeder reactor is shown in figure. The enriched uranium 235 or plutonium 239 is kept without a moderator in the reactor core, surrounded by the thick blanket of depleted uranium 238. One additional neutron available from fission of uranium 235 is used to convert uranium 238 or thorium 232 into plutonium 239 or uranium 233 as secondary fuels. This reactor also uses two liquid metal coolants in which sodium is used as primary coolant and sodium potassium as secondary coolant. Liquid sodium is circulated through reactor to carry the heat produced. The heat absorbed by sodium is transferred to secondary coolant sodium potassium in the primary heat exchanger, which in turn transfers the heat in the secondary heat exchanger called steam generator. The major difficulty with fast breeder reactor is to remove the large quantities of heat from the core, as the power density is very high, which is 40 times greater than Can-do type reactor, 13 times greater than boiling water reactor and 200 times greater than gas cooled reactor. Therefore, special coolants and special arrangements are necessary to carry out large quantity of heat. Next point is advantages of fast breeder reactor. It gives high power density than any other reactor. Therefore, small core is sufficient. Moderator is not required. Secondary feasible material by breeding are obtained. Absorption of neutron is slow. Next point is disadvantages of fast breeder reactor. It requires highly enriched, that is 15% uranium fuel. Safety must be provided against meltdown. Neutron flux is high at the center of the core. Thick shielding is necessary against radioactive radiations in primary and secondary circuits. Next type is gas cooled reactor. The gas cooled reactors with carbon dioxide gas as a coolant and graphite as moderator were first developed in England. It is called as gas cooled graphite moderator, that is GCGM reactor. The fuel was a natural uranium clad with an alloy of magnesium called magnox. The coolant pressure is about 7 bar and temperature 336 degree centigrade. USA has developed another gas cooled reactor which uses helium as coolant and graphite moderator. It is known as high temperature gas cooled reactor, that is HTGC reactor. The fuel used is uranium 233 as fissile material and thorium as fertile material. Because of very high melting point of graphite, these fuel element can operate at very high temperatures, that is 700 to 800 degree centigrade, and it is possible to generate steam at conditions equivalent to those in modern coal fired power plant. The arrangement of gas cooled reactor power plant using steam turbine is shown in figure. This is the diagram of gas cooled reactor power plant. In the primary circuit, coolant circulated is carbon dioxide for gas cooled graphite moderator reactor or helium for high temperature gas cooled reactor. The coolant transfers the heat energy to feed water in the heat exchanger. The steam generated is used to generate power in steam turbine. This is the diagram of high temperature gas cooled reactor. Figure shows the arrangement of high temperature gas cooled reactor direct cycle gas turbine plant. These types of plant uses gas turbine for power production and coolant as a helium gas. It consists a regenerator, pre-cooler and compressor. The fuel used may be uranium 233 or thorium 232. Next point is advantages of gas cooled reactor. The gases do not react chemically with the structural material like water, hence there is no corrosion problem. Graphite remains stable at high temperatures and radiation problems are minimum. Gases are safe and easy to handle. The uranium carbide and graphite are able to resist high temperatures and therefore, the problem of limiting the fuel element temperature is not as serious as in other reactor. The gas coolant provides best neutron economy. Next point is disadvantages of gas cooled reactor. Gases have poor heat transfer properties, thus it requires large heat exchangers. The pumping power required is as large as 20% of generated power against 5% with water cooled reactor. Leakage is a major problem if helium is used as in case of high temperature gas cooled reactor. Fuel loading is more elaborate and costly. Next type is liquid metal cooled reactor. Sodium graphite reactor is one of the typical liquid metal reactor. In this reactor, sodium works as a coolant and graphite works as a moderator, while the fuel used is little enriched uranium. The common metals which can be used as coolant are sodium and potassium. Sodium boils at 880 degree centigrade under atmospheric pressure and freezes at 95 degree centigrade. Hence, sodium is first melted by electric heating system and be pressurized to about 7 bar. The liquid sodium is then circulated by circulation pump. This is the diagram of liquid metal cooled reactor. The arrangement of the components of a metal cooled reactor is shown in figure. The reactor will have two coolant circuit or loops. In the primary circuit, the heat is absorbed by liquid sodium in the reactor. The liquid sodium becomes radioactive while it passes through the core and reacts chemically with water. Therefore, the heat absorbed by sodium is transferred to secondary coolant sodium potassium in the primary heat exchanger, which in turn transfers the heat in the secondary heat exchanger called steam generator. The steam generated from this steam generator will be superheated. The reactor vessel, primary circuit and primary heat exchanger have to be shielded from radiations. The liquid metal is to be handled under the cover of an inert gas such as helium to prevent contact with air while charging or draining the primary or secondary circuit. Advantages of liquid metal cooled reactor. High temperatures can be achieved in the cycle, and that means high thermal efficiency. The sodium as a coolant need not to be pressurized. The reactor size is comparatively small. The low cost graphite moderator can be used as it can retain its mechanical strength and purity at high temperatures. Superheating of steam is possible. Disadvantages of liquid metal cooled reactor. Sodium reacts violently with water and actively with air. Intermediate heat exchanger is necessary to separate radioactive sodium from water. It is necessary to shield the primary and secondary cooling system with concrete blocks as sodium becomes highly radioactive. The leak of sodium is very dangerous compared other coolant as it comes out of reactor in highly radioactive state. Next type is CANDU type reactor. Canada has developed CANDU type reactor, which means Canadian deuterium uranium type reactor. It uses pressurized heavy water, that is deuterium oxide D2O as moderator and coolant, while the fuel used is natural uranium. These reactors are more economical to those nations which do not produce enriched uranium, as the enrichment of uranium is very costly. The arrangement of the different components of CANDU type reactor is shown in figure. In this reactor, the fuel is normal uranium oxide as a small cylinder pellet. The pellets are packed in a corrosion resistance zirconium alloy tube nearly 0.5 centimeter long and 1.3 centimeter diameter to form a fuel rod. The relatively short rods are combined in bundle of 37 rods and 12 bundles are placed end to end in each pressure tubes. The total mass of fuel in the core is about 97,000 kg. The CANDU type reactor is unusual in that refueling is conducted while the reactor is operating. The coolant heavy water is passes through the fuel, pressure tubes and heat exchanger. The heavy water is circulated in the primary circuit in the same way as with a pressurized water reactor, and the steam is raised in the secondary circuit, transferring the heat in the heat exchanger to the ordinary water. The control of the reactor is achieved by varying the moderator level in the reactor, and therefore, control rods are not required. Cadmium rods are used to start and shut down the reactors. Advantages of CANDU type reactor: fuel enrichment is not required. Heavy water is used as moderator, which has higher multiplication factor and low fuel consumption. The reactor vessel may be built to withstand low pressure compared with PWR and BWR. Only the fuel tubes are designed to withstand high pressure. Therefore, the cost of the vessel is less. Less time is needed to construct the reactor. Disadvantages of CANDU type reactor: the cost of heavy water is very high. It requires high standards of design, manufacture and maintenance. The power density is considerably low compared with PWR and BWR. Therefore, the reactor size is extremely large. The leakage is a major problem, as there are two mechanical sealed closure per fuel channel. So, in conclusion, the choice of nuclear reactor type depends on various factors, including the intended purpose, safety consideration, fuel availability and technological advancements. The development of advanced reactor design and expansion of nuclear energy will continue to play a role in meeting global energy demands while addressing environmental and safety concerns. However, it is crucial to ensure that safety, non-proliferation and waste management are prioritized in the development and operation of nuclear reactors. So, this is the brief contents we discussed in this video session. We will discuss another topic of nuclear power plant in next video lecture. Thank you.